Hello everyone, I'm going to introduce the 7th section of Internal Combustion Engine, Introduction to In-Cylinder Pressure Diagnostics. There are 3 topics, including top 20 vocabulary words, in-cylinder pressure diagnostics, and the combustion analyzer operation. Part 1, top 20 vocabulary words. I will go through 20 vocabulary words. They will be mentioned in the next few slides. Please listen to the words carefully. Engine, combustion, analyzer, instantaneously, data, optimization, engineer, technician, apparatus, pressure transducer, crankshaft position signal, sensitivity, torque range, engine parameters, signals, cylinder pressure, crank offset, encoder, fuel injector, coefficient of variation. Part 2, in-cylinder pressure diagnostics. PV diagram shows the data of in-cylinder pressure against crank angle in a complete 4-stroke engine cycle. Gross indicated work and pumping work present positive work and negative work respectively. In-cylinder pressure diagram shows the maximum in-cylinder pressure occurs after top dead center in the expansion stroke. Mass fraction burned information is the result of combustion analysis. Part 3, combustion analyzer operation. Combustion analyzer operation 1. Connect the position signal line group as follows. Operating menu can follow. Turn on power to the combustion analyzer and confirm the crank position signal line and the pressure sensor is connected correctly. If the connection is good, signal light indicates amber status. If the connection is inappropriate, the signal light indicates red light. Combustion analyzer operation 2. After completing the interface connections and open EDCON software, make sure no issues with the software. Signal analyzer setting. Click on the setting column as shown in the figure below. Enter the signal range, engine parameters to establish the signal. Signal source setting. Click on the area where the red color arrow is indicating, as shown in the below figure, and select the output signal type to measure the cylinder pressure during the combustion. Pressure sensor settings, as shown in the below screenshot. This sensor's range and the sensitivity value of the sensor need to be entered. Note that different pressure sensors have different range and sensitivity value. Refer the sensor cover box for specs. After entering the values of the sensor, enter the temperature and the pressure input values of the experiments. Engine geometry setting. In here, enter the parameters of the engine cylinder bore, stroke, connecting rod, cylinder, compression ratio, and the crank offset angle. And after the entering, click on the firing order and enter time interval for the cylinders to fire. Since the experiment encoder device is not used, to determine the exact top dead center of the position by using the flywheel marking, set the position of top dead center, and then click on the auto. Crank up the engine without firing, then click on the top dead center determination to interface will set the exact top dead center position by using the pressure sensor. Note: remove the fuel injector socket to crank up the engine without firing to determine the crankshaft angle. The cylinder pressure and the peak pressure must be accurate. Major control setting. In the control mode, select the normal mode. Enter the data of the maximum crank angle and the maximum engine speed. Then enter the duration of 200 cycles. This number can be changed if needed more cycle. Recording the data. In figure below shows a box highlighted in yellow color shows the AI value. The green color shows the PCYL that shows the pressure value inside the cylinder and determine the engine running in good conditions. Whereas in the color circle, it is the recording button. The yellow circle at the bottom of the figure can check the number of cycles finished. After recording, click on the Save Data where the file stored as iFiles storage. Storage paths can be customized. It's the end of our class today. Thanks for your attention.